Hello, dear students. Hope you are doing well. Today I'm going to explain Chapter 10, Aldehydes and Ketones. The objectives that you are going to learn are: define aldehydes and ketones and identify their general molecular formulas. Name aldehydes and ketones according to the nomenclature system of IUPAC. Construct the molecular model of methanol and acetone. The last objective is to identify isomerism in aldehydes and ketones. Let us begin with introduction. Aldehydes and ketones are widespread in nature and they are responsible for the aroma which characterizes some plants. Here are some examples of aldehydes and ketones. The first example is vanillin, which comes from vanilla bean. The second example is cinnamaldehyde, which comes from cinnamon bark, and the benzaldehyde from bitter almond, and the Z-jasmine from scent of jasmine. Let us start with definition and general formula. Organic compounds which contain the carbonyl group C double bond O are called aldehydes or ketones. In an aldehyde, the carbonyl group is connected to at least one hydrogen atom. Example, the C double bond O is connected here to H and to R, or the carbonyl group is connected to two hydrogen atoms. In a ketone, the carbonyl group is connected to two alkyl groups. Here, these two alkyl groups can be either similar or different. Let us remember together what is the alkyl group. It is CnH2n plus 1. Also, let's remember the functional group of alcohol, which is OH. Here the functional group, and it is called hydroxyl group. Here in aldehydes and ketones, the functional group is C double bond O, and we call it carbonyl group. The carbon atom of the carbonyl group is the functional group carbon of the molecule of aldehydes and ketones. So let's see the first one, which is the aldehyde. The C double bond O is bonded to one hydrogen and to R, to the alkyl radical. And the second example is the ketone, where the carbonyl group C double bond O is connected to two alkyl radicals R and R prime, or they can be two similar R's. The general molecular formula of saturated carbonyl compounds with open carbon chain is CnH2nO. Now for aldehydes, the N can be equal or greater than 1. So we can start with N equal 1, and for ketones we start with N equal 3 and above. So for ketones the N is greater or equal to 3. The aldehydes is represented by the formula RC double bond H, or we can say R, or we can draw it as RCHO. So here pay attention that we write it as RCHO and not as OH. Why? Because the OH is for the representing formula for alcohol, and for ketone the formula is represented as RC double bond O R prime, or the C double bond O can be written as as CO, where here the C is bonded to the O by double covalent bond. So we can say RCO R prime. Now, the second objective is how to name aldehydes and ketones according to IUPAC system. So the systematic nomenclature of aldehydes and ketones, as in case of alcohols, is based on those of alkanes. Nomenclature of aldehydes. In naming of an aldehyde, the terminal E of the alkane is substituted with the suffix al. So the alkane that ends with E will become alkanal, ending with al. The al is, or the E is substituted by Al. Let us take examples of aldehydes. Let's start with N equal 1. The molecular formula will be CH2O. How to draw the condensed structural formula? As you see here, H bond CHO. Now, here we have the C is bonded to 2 hydrogen atom and is also bonded to oxygen as double covalent bond. The name for this condensed structural formula, or for this aldehyde, is methanal. Now, if we take N equal to, the molecular formula will be C2H4O, and the condensed structural formula will be CH3 bond CHO. Here we have 2 carbon atoms, so it means the name is ethanal, ending with Al. Remember that alcohol, the name for the alcohol is ended by OL. So the alkane that ends with E will become in alcohol alkanol. Okay, do you remember this one? So don't forget it. Now let's take the third example. For N equal 3, we have the molecular formula will be C3H6O. The condensed structural formula is CH3 bond CH2 bond CHO. Here we have 3 carbon atoms. It means the name will be propanal. It ends with Al. This is for examples of aldehydes. Let's see if this aldehyde is branched aldehyde. How do we name it? So for a branched chain of aldehydes, we proceed as for alkanes. The numbering of the carbon chain starts with carbon, which is the functional carbon, which is the carbonyl group. Now let's take example here. We have the main chain of this structural formula has 4 carbon atoms, and on the 3rd carbon atom we have the alkyl radical, which is methyl. Now, how do you number the main chain? We start numbering it from the carbon that has the carbonyl group, or we name it functional carbon. So it is 1, the second is 2, the third is a 3, and the fourth one is 4. On the third carbon there is the methyl. To name it, we start with the alkyl radical, and this alkyl radical is on the third carbon atom, so we say 3-methyl, and the main chain consists of 4 carbon atoms, so we say butanal. The whole name will be 3-methyl butanal. Note here that the carbon of the carbonyl group is always at the end of the chain. For aldehydes, it is always at the end of the chain. Now, let's see here, how do we name ketones? Ketones are named by substituting the terminal E of alkane with the suffix -one. So the alkane that has the terminal E is substituted by -one, alkanone. So example of this ketone is N equal 3. As we said, as we explained previously, that N equal 3, we have aldehyde, also we have ketone. N equal 3, the molecular formula is C3H6O. The condensed structural formula will be CH3COCH3. Here the carbonyl group is inside the chain, it is not at the end of the chain. Now, how do we name it? We say propanone. Now, for N equal 4, the molecular formula is C4H8O. And how do you draw the condensed structural formula? Is CH3CH2COCH3. Here we put a number that represent the position of the carbonyl group. So the main chain consists of 4 carbon atoms, so we say 2-butanone. It means here the carbonyl group is on the second carbon atom. Now, for ketones of N greater or equal to 4, the numbering of the carbon chain starts nearest to the functional group, which is the C double bond O. Note here that the carbonyl group in ketones is placed within the carbon chain and never at the ends. So we don't have carbonyl group at the end of the chain. If it is at the end of the chain, it will be aldehyde. So let's take examples here. And for N equal 5, we have 5 carbon atoms. The main chain consists of 5 carbon atoms. We start numbering from the carbon nearest to the functional group, which is CO. So we start numbering from the right side and not from the left side. So it is 1, 2, 3, 4, 5, and the name will be 2-pentanone. This 2 is for the position of the carbonyl group. Now, if we have here the N equal 5, and we have the instead of the main chain consists of 5 carbon atoms, we have the main chain consists of 4 carbon atoms, and we have a branch on the third carbon atom. So we start numbering nearest to the functional group, which is C double bond O, and it is the carbonyl group. And in order to name this ketone, we start naming the alkyl radical, and the position of the alkyl radical is on the third carbon atom. So we say 3-methyl 2-butanone. Now the third objective is how to construct the molecular model of methanol and acetone. Let's examine here methanol. Methanol has only one carbon atom. It is bonded to two hydrogen atoms and to the oxygen by a double covalent bond. And in this case, we have methanol, CH2O. The carbonyl group is bonded to two hydrogen atoms. These two hydrogen atoms, these two bonds are single covalent bonds. Now with respect to ketone, and we said we start with n equal 3 and above, we have 3 propanone here. The common name for propanone is acetone. As you know that acetone is to remove the nail polish, and it can be the acetone used as solvent for some organic compounds. So here the propanone has 3 carbon atoms. The second carbon atom is bonded to the oxygen by a double covalent bond, and the 2 carbon atoms on the terminal of the main chain. Here each carbon atom is bonded with 3 hydrogen atoms. These 3 hydrogen atoms, they have single covalent bond, so the carbonyl group is in the middle here. What do we have? We have ketone. Now the fourth objective is to identify isomerism in aldehydes and ketones. Isomerism of aldehydes. Aldehydes admit skeletal isomerism and positional branch isomerism. To remember these isomerism, let's take an application, write the condensed structural formulas and give the names of isomers for the molecular formula of C5H10O. Let's see here. The first isomer has 5 carbon atoms. The main chain consists of 5 carbon atoms. The first carbon atom is the carbonyl group, and we start numbering from this side, where we have the functional group, which is the carbonyl group. So what do we have here is aldehyde, and the main chain consists of 5 carbon atoms, so we name this aldehyde as pentanal. Now the second isomer, we reduce the main chain by 4 carbon atoms, and the fifth carbon atom we have it as a branch, which is the alkyl radical. It is on the second carbon atom. So start numbering with the first carbon atom, which is the functional carbon of the aldehyde. The second carbon atom has the alkyl radical, which is the methyl. You have the third carbon and the fourth carbon. So in order to name it, we name first the branch, and it is on the second carbon atom, so we name it as 2-methyl-butanal. The third isomer, which is C, we move. It is similar to the isomer B, but the difference here is the alkyl radical is on the third carbon atom. يعني we move here the alkyl radical to the third carbon atom. We get different isomers, and how to name it? We name first the branch that is bonded to the third carbon atom, so we say 3-methyl-butanal, because the main chain consists of 4 carbon atoms. Now in isomer D, we reduce the main chain to 3 carbon atoms. We have here 2 alkyl radicals on the second carbon atom. Remember here that the alkyl radical, which is CH3, can't be drawn on the third carbon atom. If we put it on the third carbon atom, it will be considered from as a main chain. So it will be as part B, as isomer B. So in this case, we can put the alkyl radical on the second carbon atom. We have 2 identical alkyl radicals. They are called methyl. So we have 2 methyl, and each methyl is on the second carbon atom, so we name it as 2, 2 dash dimethyl, because we have 2 methyl here, and the main chain consists of 3 carbon atoms, so we call it propanal. As a whole, we name this aldehyde as 2,2-dimethyl propanal. Now let us classify these isomers. In order to classify them, we'll start with the skeletal isomers. Now let's remember together, what do we mean by skeletal isomers? They have the same molecular formula, the same position of the functional group, and the main chain is different. So in this case, let's examine the 4 isomers. We see here A has 5 carbon atoms, B has 4 carbon atoms, C has also 4 carbon atoms, so we can't take B and C together. We take only A, B, and let's look at D. D has the main chain consists of 3 carbon atoms. So as we see here, A has 5 carbon atoms, B is the main chain is reduced to 4 carbon atoms, the D also the main chain is reduced to 3 carbon atoms. So we have here, we can call A, C, A, B, and D are skeletal isomers. So A, B, and D are skeletal isomers. Do you think that we have other skeletal isomers? Let's think about it. What about A, C, and D? So A, C, and D are also skeletal isomers. Can we say B and C are skeletal isomers? For sure, it is wrong. Why? Because B and C have the same main chain. Okay, so they have the same 4 carbon atoms on the main chain, so we can't call them skeletal isomers. And remember here that all the aldehydes, they have the same position of the carbonyl group. So aldehydes, they have skeletal isomers. Do you think that we have other class of isomers for aldehydes? Try to remember. What about B and C? Look at them well. Is there a difference between them? Let's see here. Both have the same main chain 4. The methyl in B is on the second carbon atom. The methyl in C is on the third carbon atom. Do you remember what do we call these 2 isomers? They are called positional branch isomers. So what are positional branch isomers? They have the same molecular formula, the same main chain, the same position of the functional group, but different position of the branch, of the same branch. Okay, so what are the positional branch isomers? They are B and C. So these are the isomers for aldehydes. Now let's take for ketones. But here I want you to pay attention that no positional isomers in aldehyde. In aldehyde we don't have positional isomers. Why? Do you remember what we mean by positional isomers? Let's remember together. The definition of it is that they have the same molecular formula, the same main chain, but the position of the functional group is different. So here, can you move the functional group of aldehyde? The answer will be no. It should be on the first carbon atom. So that's why we don't have positional isomers in aldehyde. Don't forget this, please. Now let's take the ketones and classify them. First, before classifying them, let's draw the isomers of ketones. In ketones, we start with part E. We have the main chain consists of 5 carbon atoms. The second carbon atom has the functional group C double bond O. And we name it. We have to number first nearest to the functional group, and we name it 2-pentanone. Why 2? Because the functional group is on carbon number 2. Now the isomer F, we move the functional group to the third carbon, or the third carbon has the functional group C double bond O, which is the carbonyl group. The main chain consists of 5. So what do we have? 3-pentanone. 3 because the carbonyl group is the third carbon. Okay, now part G or isomer G, we have to reduce the main chain. Instead of 5 we put 4. The carbonyl group is on the second carbon, and we have a branch on the third carbon. Do you think that we can have a branch on the fourth carbon as alkyl radical? Sure, we say no. Okay, so we have here the methyl is on the third carbon atom. The name for this isomer is a 3-methyl 2-butanone. 2-butanone because the carbonyl group is the second is on the second carbon of the main chain. Now let us classify these isomers. To classify these isomers, we have here examine well E and F. What's the difference between them? What is the similarity between them? Let's see here. Both of them have the same main chain that consists of 5 carbon atoms, but the functional group of E is the second one, and the functional group in F is the third one. So in this case, what do you think we can call these two isomers? We can say they are positional isomers. So first let's take the skeletal isomers. Okay, the skeletal isomers here we have observe them well. We have the E, which is that has the main the carbonyl group is on the second one, and the G the same position of the carbonyl group, but E has 5 carbon atoms. The G, the main chain, is reduced to 4 carbon atoms, and we have the alkyl radical. So what can we call E and G? They are skeletal isomers. Okay? Now, with respect to F and G, can we call them skeletal isomers? The answer here is no. Why? Because the position of the C double bond O is in F is on the third one, in G is on the second one. They don't have the same position of the carbonyl group. Now let's go back to what I explained about positional isomers, E and F. What do we call them? We call them positional isomers. So positional isomers are E and F. They have the same molecular formula, the same main chain, but the position of the functional group is different. Now, what do we mean the third kind of the isomers? We said first, let's remember, we explained positional isomers, we explained skeletal isomers, positional branch isomers. Now, what do we have? The fourth one is functional isomers. Functional isomers, what are they? In this case, the aldehydes and the ketones mentioned before are of formula C5H10O are functional isomers between each others. What do you mean by this? If we ask you, give us 2 functional isomers, so you can give us any aldehyde is a functional isomer of any ketone. Okay, so you can pick up any isomer of aldehydes, which that will be a functional isomer of any ketone. Now, to be sure that you understand the lesson well, I hope you will write this application. The application is to draw the isomers of N equals 6 for aldehydes and ketones using condensed structural formulas. Name each one and classify the isomers as skeletal and positional isomers. Name also 2 functional isomers. Finally, I hope all of you found interest in this lesson. Thank you.